So in section 5.2, last time we talked about polynomials or introduced you to polynomials, and we also talked about adding and subtracting them. Well, we want to follow up our operations with multiplication of polynomials, and a lot of this is going to boil down to something called the distributive property of multiplication, which means multiplication distributes over addition or subtraction. Now, in number 1 and 2 on your notes, you really won't see that applying so much, the distributive property thing, because if you remember when we talked about exponent rules, this basically is just multiplying a chain of factors, right? So, like in this first one right here, we have this monomial right here, 7y squared, multiplied by this monomial right here, 4y to the 5th. And all this is just a chain of multiplication right here. So you can actually kind of drop your parentheses and just multiply. And if you remember, we talked about the commutative rule of multiplication, which means it doesn't matter what order you multiply things in, you end up getting the same answer. So you could actually rearrange this to where it looks like this: 7 times 4, and then y squared times y to the 5th. And all this is now is just multiplying and finishing out your problem. So you'll end up getting 28 y. There's 5, 6, 7 y's total. So that's the exponent rule we talked about earlier, like a few weeks ago. So this will be 28 y to the 7th. Same thing for number 2, just over right to the other side. We have this monomial right here times this monomial. So they're two monomials being multiplied by each other. All it is just a multiplication chain. And since there's a -1 or a negative in front of that first one, we know that's like -1 a cubed b squared, and then a c to the first, and then that's 10 a to the first, b to the second, and c to the 15th. And then you're just going to multiply everything together that needs to go. Well, the -1 and the -10 make -10. There are 3 a's here and 1 a here, so that's going to make 4 a's total. There are b squared, and b squared makes b to the 4th when you add them. C to the first, c to the 15th makes c to the 16th power. So whenever you have a monomial times a monomial, basically all you're doing is just dropping your parentheses and changing the order you multiply in. Multiply things together that goes together. Now, the one that's going to first look different here is this one. So if you look on number 3 down here, this is a monomial times a binomial. And this one is going to work a little different from the previous one. And this is where you're going to have the distributive property come into play. Okay, and the distributive property is a property of real numbers. So, for instance, let's say that we had, 2 times 15. We all know that 2 times 15 is 30. You can multiply that out. But if you look, the distributive property says that, okay, let's say we write 15 is 10 plus 5, something like that. Well, the distributive property says if you multiply, the 2 can distribute over the addition. So 2 times 10 gives you 20. 2 times 5 gives you 10. And of course we know that 20 plus 10 is 30. So, distributive property is just a property of real numbers. Well, we're applying that here in the case of variables. We're abstracting it. Because that's what a lot of times we do in algebra is we're taking stuff like numbers that we know and turning them into variables. So for us right here, what's going to happen when you distribute this is this 4x is going to be distributed to 3x and distributed to 2. So here's what you would write down when you're starting out this kind of problem. You'll write 4x in parentheses and then 3x in parentheses. So the 4x goes to the 3x and then minus, and then you're going to have 4x go to the 2 right there. Okay. And now if you look, this is kind of like two mini versions of what you just did. We have now two monomials being multiplied in this first part. So that'll give us 4 times 3 gives you 12. And there's 2 x's there, so x to the second minus, and then over here, this is 4x times 2. That'll be 8x right there. And whenever you finish multiplying, you would combine like terms if you see anything that you could combine. Now, on this one right here, since this first term has x squared in it, and the second term has x in it, those are not like terms, so we can't actually go any further with this particular problem. But sometimes you're going to see once you distribute, you might have that happen. Okay, look over to number 4, just right beside it here. We have negative 2y to the third, and it's on the outside of a trinomial. So we're going to take this negative 2y to the third and basically distribute it to all 3 terms inside, all 3 of the terms of that trinomial. Now, when you have a negative that you're distributing, like negative 2y to the third, I try to very liberally use parentheses. So I would highly suggest every time you multiply the negative 2y to the third, you go ahead and make sure you have parentheses like written beside everything. So kind of see how I'm pulling everything in parentheses. So here's this minus sign right here, drop down, and then I'm going to have negative 2y to the third, which I'm distributing, multiplied by 2y. And then here's this little plus sign. I'm about to drop this little plus sign right in here. So that'll be plus, and then negative 2y to the third gets distributed to 2 or to 6 on the very end. Okay. So look how I put parentheses around everything right there, just like you saw in those earlier problems. Now we're free to multiply everything together. This first one will be negative 10 y to the 5th, since there's 3 and 2, and then minus. So whenever you multiply this is going to end up giving you negative 4 y to the 4th right there. Now there's going to be a better, cleaner way I want to write this here in a second, because if you look, there's a negative and a negative. If you remember from arithmetic, whenever you minus a negative, that actually is like you're adding a positive. So it's like double negatives kind of cancel each other out. So we're going to show you how to write that in a second as your final answer. And then over the last part it says minus 2 times 6 becomes 12 y to the third right there. Okay, so this is what we got so far. Now the only thing I want to do is clean up our signs, because if you look, when we have minus a negative, you can actually just make this plus 4y to the 4th. Those 2 negatives cancel each other out. Now if you look also over here, when you have like plus negative something like this right here, where you have like plus negative 12y to the third, something like that, you can actually honestly just write minus 12y to the third. Now I'm not sure the homework would count off if you left it plus and then in parentheses negative 12y to the third, but the cleanest way to write it is minus 12y to the third right there. And now you don't have any like parentheses that you have to deal with or anything. So yeah, this would be the cleanest way you want to write it, where I circled it right here at the end. Okay, it definitely takes a little bit of practice to see the signs, because if you're not used to seeing those can definitely throw you for a loop a little bit when you're first starting out with your multiplication and your sign numbers. One thing I would also encourage to, if you're not very good with signs, definitely have your little scientific calculator handy somewhere so you can not really have to worry about the multiplication aspect so much, because we're not really focused on the multiplication itself, like the arithmetic part. We're mostly focused on, do we know how to add exponents? Do we understand how the distribution property works? So, and then of course, do we know how to add like terms? Do we know how to recognize like terms? So if you have trouble with arithmetic issues like sign numbers, definitely have a calculator handy for that kind of stuff. Number 5. So now this one's a little bit different from even the previous 2, but if you look right here, this is a binomial right here times another binomial. Okay, so the way you're going to do this is you're actually going to use the distribution property again, but this time you're going to distribute multiple objects in the first set of parentheses. So what's going to happen here is this x is going to be multiplied by 3x, and the x is also going to be multiplied by 1. Then you're going to take this positive 2 right here and distribute it to both the 3x and the 1. So this one is where you have two things you have to distribute to clean up your answer to multiply these two polynomials. So here's what's going to happen when you distribute this. So x will be multiplied by 3x. And a lot of y'all might not have to write every little step down. You may be able to do a lot of it in your head. So you might be able to write 3x squared right out. But I'm going to write all the steps when I'm first starting these problems. We get x times 3x gives us this. X times 1. And then now we have positive 2 multiplied by 3x. So we're going to have positive 2. You can put positive 2 if you want to, but you don't have to put the positive sign, times 3x. And then we have positive 2 times that positive 1, that back in the very last number back there. So we'll have that right there, okay? Now all we do is need to multiply this out and then combine like terms if there are any. So this first term will be 3x to the second. This x times 1 will be just 1x. 2 times 3 gives positive 6. So I don't have to worry about that positive sign. And then there's going to be an x. And then this will be positive 2 times positive 1 gives positive 2. And then we have this. Now if you look here, there are some like terms in the middle. 6x and 1x will combine to make 7x's total. So this will be 3x squared plus 7x plus 2. And you can't really combine any other objects like the 3x squared. You can't add it to 7x because one has x squared, one of them has x, so those don't combine. The number 2 by itself is just going to be hanging out, so nothing else you can do with that one as well. Okay, let's go down to 6. It looks like 6 is just right below. So this one is interesting because there's a lot more minus signs in it. Now I want to show you kind of how you want to think about the minus signs. So when we distribute this 4x, it's going to go to this x, it's going to distribute to x, and then it's also going to distribute to, I would think about it as negative 6, so keep the minus with the 6 right there when you kind of multiply this out. And the same thing goes for when we distribute this 3, we're going to make this this is negative 3. So it's going to distribute to the x, and it's going to distribute to that negative 6 right there. So here's what all this looks like when you write it out. And this is where I would say definitely use your parentheses liberally. Like just throw them in everywhere you're multiplying something. So like this 4x, I want to multiply this 4x by the x. So see how I put parentheses around both the 4x and the x. And then plus. So just make it all a chain of addition right now. Just put it all added. And then we'll combine like terms, figure out the signs at the end. Next, I want to do 4x, because that's what I'm distributing, times the negative 6, the minus 6. So see how I put that minus 6 in parentheses? So I'm multiplying the 4x by the minus 6. Now, add. So just keep adding. We're going to do negative 3 multiplied by x. So now we're doing that second term up there in your first, we're doing this second term right here in that first little polynomial, that binomial. We want to multiply minus 3 times x, and then just put a plus sign. We'll do minus 3 multiplied by minus 6 right there. So this is how you want to expand it out, especially when you're first starting your problems right here. And this will end up giving you 4x to the second plus, so you can write it like this, plus, this is going to end up being negative 24x, because 6 times 4 is negative 24. If you need help, do that in your calculator, obviously. But you can actually write this, a better way to write this would be like 4x squared minus 24x. So you know how you have plus and a minus, so you can actually just now make that minus 24x. So either way is fine for now. I will say that probably the second way is the better way in the homework. It may count it wrong if you write it in the first way, but if you put parentheses, it might be all right with that. And then down here we're going to have plus negative 3x, or a better way to write that would be just minus 3x because we have plus and negative. So minus, and then last but not least, we have plus. Negative 3 and negative 6, when you multiply two negatives, you get a positive. So that'll be positive 18 right there. So that's just plus 18. Now, the very last step is combine any like terms that you might happen to see. So if you look here in the very middle, we have minus 24 and minus 3x right there. Now, with that right there, those are like terms. Negative 24, you're at negative $24 in the bank, and then you take out $3 more. Well, you're going to be at negative 27 in the bank right there. But you can, like I said, you can subtract on your calculator if you need help with the sign numbers. We get 4x squared minus 27x plus 18. And that's as far as we can go with that. That is how you multiply out those two binomials with each other. Okay. Go down and let's look at number 7. So number 7 is just an extension even more of what we just did. The only thing is you're going to take 7x and distribute it to 3 different terms in that second set of parentheses. So we have a binomial times a trinomial. And then the same thing, we're going to take negative 2, we're going to put it in parentheses every time we use it and distribute it to these 3 terms right here. So when you're writing this out, and you're welcome to fast forward past this if you need to, but when you're first writing this out, just make sure you're being careful. When you multiply everything, I put everything in parentheses. So you'll see right here, I do 7x times 2x squared right there, okay? And of course, I know that's going to end up giving me 14x to the third. Then I'm going to do plus, I'm just going to add everything for now, 7x times, the second term is negative x minus x, so keep that negative with that x, plus 7x times positive 1. So, that'll be just 7x when you apply that. But that's what you're going to have going on here. So there's those 3 right there. Now we need to take that negative 2 and multiply it by everything. So it does seem like a lot to write out. Just make sure you have a good notebook. You do get to have open notes on your midterm, so you want to make sure that you're taking good notes so you have something to kind of reference back to when you are, in case you get stuck on something, or maybe you're wondering like, oh, how did I do that in the homework? Take good notes. Have your little notebook, that you're working all your problems in. That way you'll have something to reference. And then we get this chain right here. So I did these first 3 already right here. These are these 3 right here. So I need to do that next one, negative 2 times 2x. That'll be minus 4x squared. The next one, we have negative 2 and negative x. Well, that makes positive 2x. So the negatives cancel each other out. And then negative 2 times positive 1 makes negative 2. And then, of course, the last step is combine any like terms that you might see going on here. So if you look here, the 7x squared, minus 7x squared and the minus 4x squared, those are actually like each other right there. Also, if you're looking right here, 7x and 2x make 9x. So we want to combine all these to simplify it, because the homework will want us to simplify it a little bit. So we'll simplify, and we'll get 14x to the third minus, so x squared, there's 7, 8, 9, 10, 11 of those, minus 11x squared. There are 9 x's, and then there's a minus 2 at the very end. So it takes us a while to get through it, but we end up getting the 14x cubed minus 11x squared plus 9x minus 2. So just another extension of doing distribution property, honestly. Okay. Now, there's only a few other little, you pretty much will be able to do all the homework based on this right here. There's just a few other problems that I want to show you in case you see something like these. But whenever you see something like this where it's like you have a binomial but it's like squared right here, a lot of people think that you can just, square each thing, like it's x squared and 5 squared, like that. You know, like they think that. But actually, that's not true. So you actually are going to be missing a middle term if you end up doing it like this right here. So this is not equal to this. And you can honestly go back to real numbers and verify this for yourself. Like, let's say that you had, 2 plus 3 squared right there, right? So, is this equal to 2 squared plus 3 squared? Well, I don't know. Let's verify and see. I know 2 plus 3, parentheses first, is going to be 5 squared. So is this equal to 4 plus 9? Okay, because 2 squared is 4, 3 squared is 9. 5 squared is 25. So 25 is not equal to, in this case, 13. So you can see that you don't just distribute that 2 over the addition. So exponents do not distribute over addition or subtraction. Exponents do not work that way. But how do they work? Well, what you can do is when you're on a problem like number 8, right here, you can just say, okay, well, squared means I multiply it by itself. Okay, this is x plus 5 times x plus 5. That's all that is. And now it looks very similar to something we just did in those previous problems. We're going to take this x and distribute it to the x and the 5. Okay. Then we're going to take 5 and distribute it to the x and the 5 as well. So what you end up getting is x times x, which is x squared. And I'll write this out like this, I guess, here. X times x plus x times 5. And then plus 5 times x plus 5 times 5. Okay. So this is basically what you end up having here, which gives you x squared plus 5x plus 5x. Whenever you square stuff, you're always going to see this repeat in the middle. So it's basically doubling that middle part right there. And this will be 25 right there. So we get x squared plus 10x plus 25. So, part of it is like, if you look back at the original problem, part of it was like, you took that first term squared and you took that last term and squared it. So they're part of your answer. But if you had just said, oh, it's x squared plus 5 squared, or, x squared plus 25, that's the only answer, you're missing that 10x that's in the very middle. Because you're basically saying, okay, take x, 5, take 5 and take x, multiply them together, and then double whatever that is. So there is a pattern once you realize, basically how these work. There's a pattern you can see to get your answer real quick, which, may not come into play too much with you doing this, but, in future sections, we are actually going to be kind of reversing the process. So we're going to be breaking the terms back apart, okay? So you're going to be seeing us undoing kind of what we did in this section, like making it go back into its individual factors. So we'll be showing you that in a little while for sure. But yeah, let's do another example just so you have it. So down here, we see that this is 3x and 2y squared. So what I would just do is break it down where it's repeated. So that's 3x plus 2y, 3x plus 2y. And then I'm going to distribute that 3x to both of those terms. So that'll be 3x times 3x. And then plus 3x times 2y. Okay, and then plus. Okay, now I want to distribute that 2y to both of those terms. So that'll be 2y times 3x, and then a 2y times a 2y. Okay, now we just want to clean up each one. This will be 9x to the second, 6xy, 2 times 3 is 6xy again. So you're always going to see these repeat. I usually, with the variables, I write them in alphabetical order. So you could do y times x, but that's the same as x times y. And then plus 4y squared. The only thing we really need to clean up here is these middle terms. These are both xy terms, so we can make these combine so that we have plus 12xy. So we'll end up getting 9x squared plus 12yx, or xy, plus 4y squared right there. Okay. And you can do the same thing for number 10 as well. Now number 10, there is a negative 9. So whenever you're distributing that negative 9, just be real careful on that. This will be x minus 9 times x minus 9. So I'm going to distribute my x to the other x, and then I'm going to also distribute x to that negative 9. So basically what I did here was I took x, multiplied it by x, and multiplied it by negative 9. Now I'm going to keep going, so just keep it in a chain of addition for now. Negative 9 now is what I want to distribute. So this time I want to take this negative 9 that's right here and distribute it to the x and distribute it to the negative 9. So I'm basically distributing that negative 9. Okay. And this is how you could write it out right here before you go ahead and multiply it out. So we end up getting x squared minus 9x minus 9x. Negative 9 and negative 9 make 81 positive. And then we finally get x squared minus 18x plus 81. Okay, scrolling on down just a little bit more, just a couple more examples in this section, but we have these two right here. Now, if you notice right here how it has like x plus 4 and x minus 4 right here, these are actually called conjugates, where the sign in the middle is the only thing that's really different with the two. Whenever you have this happening here, you're going to see something interesting, I guess, fall out. It's the middle term is going to end up dropping away every time. And you're going to see why that is whenever we distribute these. So when you take the x and multiply it by x, obviously that'll give you x squared when you do that. So you'll get x squared. Then when you take the x times negative 4, that'll give you minus 4x right there. So that's the first two terms. Well, don't forget we now have to, after we do these two, now we have to go back and multiply this 4 times both of these as well. Okay. Well, this will give positive 4 and x will give positive 4x. Positive 4 and negative 4 will give negative 16 overall. So there's those two factors. Now, look in the very middle at these two terms. Minus 4x and positive 4x. Those will basically add together and give 0. So what you're going to see every time when you see conjugates, you're going to see them two drop out and you end up getting just x squared and the minus 16. So it's basically like we just took the x multiplied by x and the 4 multiplied by 4. The middle stuff didn't end up working out, and then you have a minus sign between it. Okay, so it is good to recognize this for later whenever you have stuff that breaks down, because eventually where we're going to go with this is we're going to have to break this back up into what it originally was. And what we know here, since it's two perfect squares, like this is x squared and this is 4 squared, we know that this will be x plus 4, x minus 4 when we break it back up. Or you can write it either way, x minus 4, x plus 4, or x plus 4, x minus 4. That's going to basically break back up into that right there. Because eventually we're going to be thinking about, okay, how can we take something that's complicated and kind of break it back up into separate pieces. That's called factoring, which we are going to get into very soon. But you can definitely be on the lookout, like, oh, when I see a perfect square minus another perfect square, you know, that's going to break into conjugates. That's going to break into x plus something, x minus something. So, you know, getting your mindset for that can prepare you for some things to come. Let's do another one, though, just to kind of show you. So, in this one right here, I'm going to take this 3m that's right here, multiply it by 3m, multiply it by 6. Then I'm going to take this minus 6, multiply it by 3m and positive 6 as well. So we end up getting here on this next line, 3m times 3m plus, I'm going to keep it all in an addition chain for now, 3m times 6 plus negative 6 being distributed to 3m and plus a negative 6 being distributed to a positive 6. So there's my 4 things that I'm distributing right there. And now I want to go ahead and combine or multiply things out. This will give you 9m squared. This will be 3 and 6 make 18. Yeah. Minus, that'll be 18 as well. Right there. And then this will be negative 6 and positive 6 make minus 36 right there. Okay. And what I want to do now is go ahead and combine my like terms. So this will be, now 18 and negative 18, notice those cancel out. So all we have is 9m squared and 36. So if you can recognize some things, you might be able to shortcut and jump straight to that last step right there. And you know, if you're thinking ahead a little bit, we know to get 9m squared, we had to take 3m and square it. To get 36 squared, we had to take 6 squared to get that. So later on, we will be factoring this into 3m minus 6, 3m plus 6 later on. Section, I think it's 5.3 maybe, where we start factoring. Okay. And if you got any questions, feel free to message me.